Good morning, everyone, and a warm good morning to all students. So, welcome back to the chemistry webinar. And today it's the continuation of haloarenes topic, children. See, yesterday you have learned about the haloarenes, see their preparations. In the preparations, you have learned about the Sandmeyer's reaction and Gattermann's reaction, isn't it? And you have learned about the nucleophilic substitution reactions yesterday. And today, Archana ma'am is going to deal about the remaining electrophilic substitution reactions and then the properties of haloarenes. And then at the end, she is going to deal with the polyhalogen compounds, see their uses and their preparations. So good morning, Archana ma'am.
Good morning, ma'am.
So please welcome, ma'am. So I would like to hand over the session to Archana ma'am.
Okay. Good morning, children. Today we are going to discuss some more topics from haloarenes. Before going to discuss about this session or start this session, we will recall the one what we have discussed in last class. So we discussed the classification of haloarenes, nomenclature. In that we learn how to write the name for the haloarenes. I think so, children, you practiced at home how to write the IUPAC names and common names to the haloarenes. And also we discussed how to prepare the haloarenes. In that one, mainly we discussed the Sandmeyer's reaction, Gattermann reaction. Sandmeyer reaction means you already learned that when aniline is treated with sodium nitrite, so at 5 degrees Celsius, it gives benzene diazonium salt. That benzene diazonium salt, once again treated with cuprous chloride, then you are going to get haloarene. This is the Sandmeyer's reaction we learned, and Gattermann's reaction also very important that we learned. So in this introduction of chlorine or bromine into the benzene ring is going to be takes place. So when benzene diazonium salt is treated with halo acid in presence of which one? Copper powder. That we are calling them as Sandmeyer reaction. All these two methods we are used for the preparation of haloarenes that we already learned in the last session. And also we discussed the physical properties, melting points, boiling points, solubility, those we discussed. Under chemical properties, we discussed the nucleophilic substitution reactions. And a very important point here I told to you, so you have to remember that when we compare the haloalkanes and haloarenes, so these haloarenes are less reactive towards nucleophilic substitution reactions, I told. Why? Because there are the three reasons I told. One is the resonance effect. Due to that effect, CX bond attains the double bond character. And next one, hybridization of carbon. And third one, polarity of CX bond is less. So due to these reasons, this aromatic, that means haloarene is having less reactivity towards nucleophilic substitution reactions. And next, we learned that so in place of the CX, that means X is going to be replaced by some of the nucleophiles such as OH, cyanide, and NH2 groups are the nucleophiles which are going to be so attacked at the benzene ring that we learned in the nucleophilic substitution reactions. Today, we are going to discuss some more chemical properties of haloarenes, that is electrophilic substitution reactions. We have to discuss in detail with the mechanisms and reactions with metals. So how these haloarenes are going to react with the metals that we have to discuss, and polyhalogen compounds. So what are polyhalogen compounds means? Yeah, carbon compounds having more than one halogen, we are calling them as polyhalogen compounds. And we are having so many examples under that one. We have to discuss in detail uses, preparations in that one. Let us start with the chemical electrophilic substitution reactions. Under chemical properties, we have to discuss one more topic, electrophilic substitution reactions. Children, you know what is meant by electrophilic substitution reactions. You already know substitution reactions means one atom is going to be substituted by another atom. So electrophilic means electrophiles. So what are electrophiles here? Electrophiles means electron deficient species. Electrophiles means electron deficient species. See here, electrophilic substitution reactions of haloarenes when we compared with the benzene. You already learned benzene will also undergoes the electrophilic substitution reactions. But when we compare benzene with the haloarenes, these haloarenes, they are undergoing the electrophilic substitution reactions slowly, and they requires the drastic conditions to undergo electrophilic substitution reactions. Why? This we have to discuss. And we know that halogen atom is being slightly deactivated. You know, in your first year itself, we learned that these halogens are slightly deactivated and they are ortho-para directing groups. They are ortho, para directing groups. Therefore, what happens here? Electrophilic substitution in haloarenes. So, where the electrophile is going to be attacked means it is going to be attacked at ortho and para positions. So, with respect to the halogen atom, so these haloarenes, so they are undergoing the electrophilic substitution reactions. So that means we have to remember that due to the halogen atom slightly deactivated, it is a ortho-para directing group. So therefore, electrophiles are going to be attacked at ortho-para positions only. So now next, remember children here, they are undergoing the slow electrophilic substitution reactions. Why? Because see here, due to the negative inductive effect of halogen atom, that means halogen atoms, they are having the negative inductive effect. So due to that, what happens? So it is going to be withdraw the electrons from the benzene ring. What it is doing? The halogen which is going to be present on the benzene ring, it is going to be
Children, as there is.
So dear children, so please stay online due to some technical problems. Like madam has left the meeting. Once again, she is going to join the meeting. Until then, you just recall the reactions which you have learned yesterday. See, what is Sandmeyer's reaction? See, Sandmeyer's reaction is preparation of haloarenes from benzene diazonium chloride. When benzene diazonium chloride is treated with copper chloride and HCl, it gives chlorobenzene. And when it is treated with copper bromide and HBr, it gives bromobenzene, right? So please learn these reactions, what you have learned yesterday until madam joins the meeting. Okay, children? So sorry for the inconvenience. Archana madam. Can you start the session? Dear children, please observe the difference between Gattermann's reaction and Sandmeyer's reaction. Right? See, when you take copper and HCl, it is Gattermann's reaction. And when you take copper chloride along with HCl, it is Sandmeyer's reaction. See, children, please prepare all the name reactions. Already you have learned from alkyl halides and haloarenes. In alkyl halides, what do we learn? So we learn about Williamson synthesis. See, what is Williamson synthesis? When ethyl chloride is treated with sodium ethoxide, it gives ether, right? So that is called as Williamson synthesis. See, please write all the name reactions in one book, right? So in one place such that you can every day go through the name reactions. So in your first year, you have learned about the Wurtz reaction also. So please learn all the name reactions. So Archana ma'am is back.
Yes, madam.
Archana ma'am, please continue. Your voice is not heard, ma'am.
Hello, madam.
Yes, madam. See, children, what we were discussing is about the Williamson synthesis, right? See, what is Williamson synthesis? When alkyl halides, that take the example of ethyl chloride, when it is treated with sodium ethoxide. So what does it give? It gives diethyl ether. So that is called as Williamson synthesis. And then I was telling you about the Wurtz reaction. See, Wurtz reaction, by Wurtz reaction, we can
Madam, please unmute yourself.
yes, madam. I'm sorry. I thought that.
And please continue.
Yes, madam. Dear children, I was discussing about the Williamson synthesis and Wurtz reaction. See, what is Wurtz reaction? See, in Wurtz reaction, we can prepare higher alkanes. So when you take 2 moles of alkyl halides, and when it is treated with metallic sodium in the presence of dry ether, see, what is ether? Ether is a solvent, isn't it? So what do we get? We get higher alkanes. So that is Wurtz reaction. And then please go through the name reactions, what you have learned from yesterday's session. The madam has explained you about the Sandmeyer's reaction and Gattermann's reaction, isn't it? Okay, welcome ma'am. So please start sharing the screen, ma'am.
Yes, madam. 1 minute.
So please try to understand the basics of nucleophilic substitution also, children. See, what is substitution? The process of replacement of an atom or a group with another atom or another group is called as substitution. If this substitution is being done by a nucleophile, what is a nucleophile? A nucleus-loving species, right?
Shall I
Or an
continue, ma'am?
electron-rich species. Okay, madam. Yeah,
Okay.
thank you.
Children, sorry for the disturbance. Okay, we are discussing here how the haloarenes, that means electrophiles, where they are going to be attacked, that we had to discuss. In haloarenes, electron density is more at ortho and para positions. So how we will know whether they are more electron density at ortho para positions means due to the resonance structure. See, children, here, due to the resonance structure. So what are the resonance structures? See here, there are the 3 resonance structures of this haloarene is there. Due to this, here you are observing that where the negative charge is going to be present means at ortho and para positions. So electron density is going to be more at ortho and para positions. So wherever the electron density is more, there only the electrophiles are going to be attacked. That we are calling them as electrophilic substitution reactions. Next, we will discuss here mechanism. See here, whenever they are undergoing the electrophilic substitution reactions, you learned in your inter-first year itself, it is a 3-step mechanism. So first step, generation of an electrophile will take place. Is it right? First step, generation of an electrophile. Second step is, so there is a formation of intermediate carbocation. There is a formation of intermediate carbocation. Third step is a removal of proton takes place in the case of the electrophilic substitution reactions. So these 3-step mechanism you already learned in your first year itself. So here we will see that what is happening in haloarenes. In haloarenes, when electrophile is attacked at ortho position, see what happens? There is a generation of intermediate carbocation. There is a generation of intermediate carbocation. This intermediate carbocation is going to be destabilized. Why it is going to be destabilized? See, children, due to the presence of negative inductive effect of halogen. Just now I told, due to the negative inductive of halogen. See where the halogen, this is the halogen. It is going to be have the negative inductive of halogen. So due to this, it is going to be destabilize the intermediate carbocation. It is going to be destabilize this intermediate carbocation. And next, what is happening here? See, so electrophile is going to be attacked at which positions? Ortho or para position. So here ortho position electrophile attack and para position also electrophile attacked. So due to this, what happens? See here, the resonance effect will stabilize the intermediate carbocation. See here how the resonance is going to be takes place here. Whenever the lone pair electrons present on this halogen is participate, it is undergoing the conjugation with the pi electrons of the benzene ring. They are undergoing the conjugation with the pi electrons of benzene ring. When they are undergoing, resonance structures are going to be possible. Due to this resonance effect, it is going to be stabilize the intermediate carbocation. So like this, the mechanism is going to be involved in haloarenes electrophilic substitution reactions. Next, we will discuss. So what are the electrophilic substitution reactions? These haloarenes are undergoing. The first one is halogenation, nitration, sulphonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. All these reactions are come under electrophilic substitution reactions of haloarenes. We will discuss one by one. So what is meant by halogenation? The term itself is giving the meaning. Halogenation. Halogenation means here, which is the electrophile here means halogen is the electrophile. This halogen is going to be attached at the which position? So ortho or para position. Why? Because we learned that the electron density is more at ortho and para positions. See, halogenation means when haloarenes react with halogen in presence of Lewis acid like so ferric chloride, it yields the dichlorobenzene. It yields the or it forms the dichlorobenzene. Let us see the reaction. So when chlorobenzene reacts with chlorine in presence of Lewis acid like ferric chloride, it gives the dichlorobenzene. Dichlorobenzene. Let us see the nomenclature, IUPAC nomenclature, how we can write. You know, whenever two substances are there on benzene ring, we have to give the numbering. See, first position is the second position. Therefore, what we have to write? 1, 2. So how many are there? 2 are there. So di, we have to use the word di. Dichlorobenzene. 1, 2, dichlorobenzene. If you want to write the common name, how we can write it? At which position halogen is there? Ortho. So ortho dichlorobenzene. Ortho dichlorobenzene. Like that we have to write the name. And next, come to this one more product is possible. Why? So both electron density more at ortho and para positions. So therefore, one more product here is 1,4 dichlorobenzene. 1,4 dichlorobenzene is formed, and there is a removal of HCl is going to be removed. So this is called halogenation. Halogenation means when haloarenes react with halogens in presence of Lewis acid like ferric chloride, it forms dihaloarenes. That means dihaloarenes. So that is called halogenation. Children, what is the electrophile here? So here the electrophile is Cl+. Cl+ is the electrophile which is going to be attacked at this ortho position or it is going to be attacked at the para position. Therefore, two products are possible. In these two products, the para product is the major product. Which is the major product means para will be the major product. So this is about halogenation. And the next one is nitration. So what is meant by nitration? How the electrophile is generated. The first step itself in these mechanisms is what is generation of electrophile. So here nitration of haloarenes required. So what we required here? Nitric acid and sulfuric acid. When we mix nitric acid and sulfuric acid, it gives that means it is going to generate a nitronium ion. So which is going to be acts as a electrophile. See children, so this is generates the nitronium ion which is act as a electrophile. So now what we have to do? This electrophile should attack at which position? So ortho or para position. It will be same for all the one. So you have to remember that both ortho and para products are going to be formed. See the reaction here when chlorobenzene is going to be reacted. See here when chlorobenzene react with nitric acid and sulfuric acid, so it results to get that means here 2-chloronitrobenzene. Why we are giving the here means whenever any functional groups are going to be present, and that we have to see, and which position is there chlorine. This is the first position nitro, and the second one will be the 2-chloro. So therefore we are giving the name as 2-chloronitrobenzene. So one more product is at which position the chlorine here? The first position 1, 2, 3, 4. At fourth position chlorine is there. Therefore we are calling that IUPAC name as 4-chloronitrobenzene. We are calling them as 4-chloronitrobenzene. So these are the main products are going to be formed in this nitration. So what is happening here? The electrophile, nitronium electrophile is attacked at this position, and lastly in the third step what happens? There is a removal of hydrogen at this position is taken place. So this is about nitration. Chlorobenzene reacts with nitric acid and sulfuric acid mixture. On heating, you are getting 2-chloronitrobenzene and 4-chloronitrobenzenes. So this is about nitration. So here also it is undergoing electrophilic substitution reactions. Next one is sulphonation. So what is meant by sulphonation? See children here, a replacement of hydrogen atom by which group? Sulphonic acid group. So here sulphonic acid group is acting as electrophile. Sulphonic acid group is acting as electrophile. So this is going to be replaced by which one? Means hydrogen atom in this haloarene. So that is called as sulphonation. What is meant by sulphonation? A replacement of hydrogen atom by a sulphonic acid group in a ring is called sulphonation. It is carried out by heating the chlorobenzene. So that means here when you are taking, see here what is the first starting here? Chlorobenzene. When it is going to be react with oleum, oleum means fuming sulfuric acid. We are calling that one as a fuming sulfuric acid. So when this chlorobenzene reacts with this fuming sulfuric acid, it forms 2-chlorobenzene plus 4-chlorobenzene sulphonic acid. Sorry, 2-chlorobenzene sulphonic acid and 4-chlorosulphonic acid. Here also we have to give the preference to this sulphonic group. Therefore, give the numbering from here. 1, 2, 3, 4, 5, 6. Like that we have to do. So at which position the chlorine is there? Second position. So 2-chlorobenzene sulphonic acid. We have to give the name as this is sulphonic acid group. Therefore, 2-chloro on which it is there? Benzene. So sulphonic acid. Next one is next product 4-chlorobenzene sulphonic acid. 4-chlorobenzene sulphonic acid. So this is called sulphonation. So replacement of hydrogen by a sulphonic acid group, that we are calling them as sulphonation. Next one, a very important one for your examination point of view, Friedel-Crafts alkylation reaction. So this also you learn in your intermediate first year. So what is meant by Friedel-Crafts alkylation? See, when chlorobenzene is treated with, so here alkyl halide, so chlorobenzene treated with alkyl halide in presence of anhydrous aluminum chloride, So what are the products you are getting here? 1-chloro-2-methyl-benzene. So alkylation of benzene is going to be takes place here. So what is the electrophile here? Means CH3 plus is the electrophile, which is the electrophile generated here means CH3 plus is the electrophile. That CH3 plus is going to be replaced by the hydrogen at ortho position C or at para position. Therefore, two products are formed here. See children, here when you observe these two products, here two substituents are there. What are the substituents? One will be the chlorine, the next will be the methyl one. So how we have to give the numbering here? So we have to follow the which rule here? Whenever two or more substituents are there, we have to follow the alphabetical order. So which one will comes first here? So chloro will comes first, then methyl will comes in alphabetical order. Therefore, we have to give the numbering as 1-chloro-2-methyl-benzene. 1-chloro. So here when you are taken starts here 1, 2. At which position methyl group is there? Second position. So 1-chloro-2-methyl-benzene. So this is the minor product. So one more product here is, so 1-chloro, at which position the methyl group is there? Fourth position. So therefore 1-chloro-4-methyl-benzene is the major product is going to be formed in the case of the Friedel-Crafts alkylation. So clear children? So what is meant by Friedel-Crafts reaction means when chlorobenzene or haloarene reacts with haloalkanes in presence of anhydrous aluminum chloride, trichloride, it results to form 1-chloro-2-methyl-benzene, or next one is 1-chloro-4-methyl-benzene. So these are the products are going to be formed in Friedel-Crafts alkylation. The term itself is giving with the help of this Friedel-Crafts Gattermann reaction, what is going to be happening? Alkylation. So that means alkyl group is going to be added onto the benzene ring. So therefore, this we are calling them as Friedel-Crafts alkylation reaction. So one more we have, children. This is also very important for your examination. Friedel-Crafts acylation. So only the term is going to be different. Alkylation, acylation. Alkylation means alkyl group. Which is alkyl group there? Methyl is the alkyl group, is going to be attached to the benzene ring at ortho or para position. Here, acylation. So whenever chlorobenzene is react with an acyl halide, see, this is the acyl halide, CH3, C double bond O, Cl. Acyl halide or acid anhydride. It is going, if it is going to be react with acid anhydride in presence of same anhydrous aluminum trichloride, so it gives 2-chloroacetophenone. So how we have to write the name for this one? See here, when you are coming to this one, here these two are not substituents. Here one will be the functional group. So here this will be the keto functional group. This is the ketone functional group, and this will be the substituents. When functional group is there and substituent is there, in order to write the IUPAC names, so we have to follow the rules here also. So which one we have to give the preference? We have to give the preference to which one? Functional group we have to give the preference. So now give the preference to this functional group. So where the functional group, ketone functional group is there? Here, this position. So give the numbering from here. 1, 2. So now where the chlorine is present? At second position. Therefore, write the name as 2-chloroacetophenone. So 2-chloro, this is aceto, ketone, end with the on. So 2-chloroacetophenone. And next product is 4-chloroacetophenone. The next product is 4-chloroacetophenone. So these are the products, major products are going to be formed in this one. So this is called Friedel-Crafts acylation. Means when chlorobenzene react with an acyl halide in presence of anhydrous aluminum trichloride, it gives 2-chloroacetophenone and 4-chloroacetophenone. So when you compare these two products, which is the major product, means this will be the major products. So this is about Friedel-Crafts acylation. So here, which is the electrophile? Acyl group is the acyl chloride is the one when you are taken, this will be the electrophile. So C double bond O, CH3, CH3, C double bond O plus is the electrophile. Which is the electrophile generated here? Acyl, CH3, C double bond O plus. So that electrophile attacked at ortho and para position. This is called as Friedel-Crafts acylation reaction. Next, we will discuss the one. So with this, we completed the electrophilic substitution reactions. What we completed? Halogenation, nitration, sulphonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. Next, the third reaction. So these haloarenes are ready to react with which one? Means metals. Therefore, we have to discuss the reactions with metals. So first one is Wurtz-Fitting reaction. Wurtz-Fitting reaction. So what is meant by Wurtz-Fitting reaction? See, when haloarenes react with haloalkane and heated with sodium metal in presence of dry ether. See here one more time, haloarenes when react with alkyl halides or when you are taking haloalkanes, so react with sodium metal in presence of dry ether, then it gives the alkyl benzene. It gives what? This is R means alkyl benzene. So therefore, this is called as Wurtz-Fitting reaction. This is called as Wurtz-Fitting reaction. So what is meant by Wurtz-Fitting reaction, see children? When haloarenes react with haloalkanes with which metal? Sodium metal in presence of dry ether. So what is the product we are getting? Alkyl benzene is the product we are getting, plus sodium halide. So it is going to be removed as NaX. It is going to be removed as NX. Sodium halide, it is going to be removed. That is called Wurtz-Fitting reaction. One more time. Haloarenes react with haloalkanes when heated with which metal? Sodium in presence of alkyl benzene. So this is called as the Wurtz-Fitting reaction. What is the product? Alkyl benzene is the product formed in this Wurtz-Fitting reaction. Next one is the fitting reaction. What is the difference between the Wurtz-Fitting and the fitting reactions? Means everything will be same, but only the difference is two haloarenes are going to be react here. There is no haloalkane here. So we are going to be taking the two haloarenes when they are reacting with sodium metal in presence of dry ether. So these two aryl groups, they are going to be combined and they are going to be give a biaryl products. Biaryl products. So this is a biaryl product. Bi means two aryl groups are going to be attached. Therefore, this we are calling them as a fitting reaction. This we are calling them as a fitting reaction. In Wurtz-Fitting, haloarenes react with haloalkanes with sodium metal in presence of dry ether. There, the one you are taking, the one alkyl benzene you are getting. Here, when you are taking haloarenes, two haloarenes, they are going to be react with sodium metal in presence of dry ether. You are going to get one of the biaryl product that we are calling them as a diphenyl one. What is the biaryl product here? Diphenyl group is going to be formed. This reaction is called as a fitting reaction. So these are the two reactions we can study under the reactions of haloarenes with metals, Wurtz-Fitting reaction and fitting reaction. So this is about the chemical reactions. Nucleophilic substitution reactions we completed, electrophilic substitution reactions we completed, and reaction with metals we completed. Next, we can move on to the next one, most habiting polyhalogen compounds. So here, what is meant by polyhalogen compounds? Means carbon compounds which contains more than one halogen atom, that we are calling them as polyhalogen compounds. That means here we have so many polyhalogen compounds, dichloromethane, trichloromethane, triiodomethane. See here, so these are the examples for this one: dichloromethane, trichloromethane, triiodomethane, tetrachloromethane, Freons, DDT. All these are the examples come under polyhalogen compounds. So many polyhalogen compounds are there, but we are going to be discuss some of the important polyhalogen compounds here. We will discuss one by one with the preparation and properties uses. So first one is dichloromethane. So what is the formula for dichloromethane? Di means two. So two chlorines are there. Dichloromethane, how many carbons are there? Only one carbon. So therefore, this is dichloromethane. Let us discuss what are the properties of dichloromethane. So it is a colorless one and sweet smelling, and it is going to be a volatile liquid. So this dichloromethane is a colorless one, sweet smelling and volatile liquid, and it is going to be have the low boiling points, and also they are having the less inflammability. And if we come to the solubility, they are insoluble in water. See children, they are insoluble in water. So this we already learned. They are going to be soluble in non-polar solvents. Therefore, they are going to be insoluble in water. So these are the properties of dichloromethane. And next we will discuss where we are using this dichloromethane. So this we are using widely as a paint remover. So for the removal of paint, this is a general example where we are using this dichloromethane. Means we are using for the removal of paints. We can use it this one. And also, I told these compounds are going to be used as a solvent for many of the organic compounds. See, therefore, this dichloromethane is used as a solvent and also cleaning agent in chemical manufacture and textile industries. We can use it as a cleaning agent, and electronics, metals, and industries also we are using this as a cleaning agent. And also it is also used as a process solvent in manufacture of drugs. So that means for the preparation of drugs also we are using this one as one of the solvent. So these are the uses for dichloromethane. Next, we will discuss the next one, trichloromethane. Trichloromethane, what is the formula here? Trichloro means 3 chlorines are there. So what is the formula here? 3 chlorines are there, therefore CHCl3. In methane, replace the 3 hydrogens by chlorine, then you are going to get the chloroform. That is, we are common name, we are calling them as chloroform. What is chloroform means? Trichloromethane. The formula is CHCl3. So how it is going to be prepared? So this chloroform is prepared by chlorination of methane. See children here, it is going to be prepared by chlorination of methane followed by fractional distillation. Chlorination of methane followed by fractional distillation. Then we are going to get chloroform. We are going to get the chloroform. Like this, we are going to be prepared the chloroform in industry. So when chlorination of methane is undergoing the chlorination process. So followed by which one? Fractional distillation. So that we are calling them as, in this way, we can prepare the chloroform in industries. And what are the properties of chloroform? Chloroform is having the sweet smelling liquid, and chloroform is one more thing very important. It is going to be slowly oxidized in presence of the light. So if you open the chloroform, so in presence of light, what happens? It is undergoing the oxidation reaction. Slowly it is going to be oxidized. When it is undergoing the oxidation or so oxidized in presence of light, what happens? There is a toxic gas is going to be released. So which is the toxic gas here? Phosgene is the toxic gas is going to be released. See here, when chloroform oxidizes in presence of light. See here, when chloroform oxidizes in presence of light. So which is the toxic gas released here? Phosgene. What is the formula for phosgene? COCl2 is formed. So here this gas, that means in order to avoid the formation of this poisonous gas, so what we have to do? So that we will see, these should be stored in dark colored bottles so tightly. That means here, see, to avoid this oxidation of chloroform, what we have to do? They should be stored in dark colored bottles completely, so that what happens, air cannot be entered into it. So due to this, we can avoid the oxidation of this chloroform. And where we are using this trichloromethane, see, chloroform is used as a solvent in which one? Fats, alkaloids we can use it, and also iodine and other substances we can use as a solvent. And also very important one, this one, it is mainly used in the production of Freon refrigerant. See last one, the use, it is going to be used in Freon refrigerant we are going to be used. So for the production of Freon refrigerant R22, so we are going to be used, which one means chloroform. So this is about uses of trichloromethane. Next we will discuss so triiodomethane. So we are calling them as iodoform. 3 hydrogens in a methane are replaced by which one? So iodine. Therefore we are calling that one as so iodoform, triiodomethane. So how it is going to be prepared? See here, so any compound which is going to be contain so CH3CO group or CH3CHOH group. So when they are going to be heated with which one? Iodine, and so yellow precipitate you are going to get. So when these compounds, when they react with iodine, if you are going to get yellow precipitate, that we are calling them as a iodoform. So this reaction is known as iodoform reaction. So, and this iodoform is also prepared by using bleaching powder. This can also prepared by using bleaching powder, CaOCl2. So it can be prepared. Next one, the uses of iodoform. So where we are, generally, you know, this iodoform was used earlier as an antiseptic. Whenever we are having the wounds, then we are going to be used for that purpose, that we are calling them as an antiseptic purpose we are using. But so due to the liberation of free iodines, they used as antiseptic. Now what happens? Due to objections to their smell, it has been replaced by some of the formulations containing the iodine. Now we are not using directly the iodoform, we are using the formulations. In that which is going to be present means iodine is going to be present. Those formulations which are having the iodine, that we are going to be used as antiseptic. So this is about the uses of iodoform. Next, we can move on to carbon tetrachloride. All the hydrogens in methane are replaced by the chlorines. So what is the formula for carbon tetrachloride? CCl4. So how this is prepared means it is prepared by reacting of disulfide with chlorine. So in presence of aluminum trichloride, then you are going to get the carbon tetrachloride. So it is going to be prepared by, so when carbon disulfide reacts with chlorine in presence of aluminum trichloride, you are going to get which one? Carbon tetrachloride. So this is one of the preparation. So in industry, they are preparing the tetrachloromethane. So properties of tetrachloromethane. Iodoform is a colorless one, non-inflammable, and it is a poisonous liquid, So these are the some of the properties. Next we will discuss, so where we are using this tetrachloromethane. See children, we are used as a solvent for, so that means just now first itself I told, these are compounds we are using as a solvent for many organic compounds, non-polar solvents. So therefore this carbon tetrachloride used as a solvent for oils, fats and resins we are using. And here it is used as a refrigerant for, and also dry cleaning agent. We can also use as a refrigerant, and you can also use as this one as a dry cleaning agent. And it is used in fire extinguishers. We can also use it as in fire extinguishers, you know. So in fire extinguishers also we are using the carbon tetrachloride under the name pyrene. We are using under the name pyrene. So these are the some of the uses of carbon tetrachloride. Next polyhalogen here is Freons. So nowadays we are hearing this one Freons. What happens whenever the more number of Freons are going to be released into the atmosphere? What happens means depletion of ozone layer is going to be takes place. So this is the main reason why the depletion of the ozone layer is going to be taken place. So let us see how it is going to be prepared. So preparation of the Freons. Difluoromethane. So one of the common freon. So what is the name? Dichloro. Two chlorines are there. Difluoro. So difluoromethane. This is the common one we are using in the manufacture also. This can be prepared by, so tetrachloromethane by Schwartz reaction. We can use, we can prepare by which reaction? Schwartz reaction. We can easily prepare this difluoromethane can be easily prepared. Now let us see properties. So freons are extremely stable and unreactive. They are very stable. Therefore, if releasing of more freons are there, so they will not destroy easily. And also they are non-toxic, non-corrosive and easily liquefiable gases. They can be converted into liquids easily. So these are the some of the properties. They are extremely stable, unreactive, non-toxic, non-corrosive and easily liquefiable gases. So these are the properties of freons. Next, come to one. So just now I told, so when more number of the freons are going to be released, what is going to be happening means depletion of ozone layer is going to be takes place. This is the main product which leads to the depletion of ozone layer. And also we heard that there is a ozone layer is going to be have the holes. So with this, what is happening when ozone holes are formed? What happens here? So ultraviolet rays are directly falls in onto human being skin. So what happens? Skin diseases we are getting. We are getting the more skin diseases, and we are getting the eye irritations. All those things we are getting. So what we have to do now? That means we have to reduce the use of the freons. We had to reduce the use of the freons. That's why we are, that means celebrating the ozone day also. So why we are discussing the ozone day separately means because of what are the factors which are responsible for the depletion of the ozone layer, those we have to decrease it. That means we have to save our ozone layer. Very, very important one. Let us see. So uses of freons, where we are using. Freons are used in aerosol propellants and refrigeration, air conditioning purpose. We are using in the mainly refrigerators we are using, and also we are used as a air conditioning purpose. That means what we have to do, we had to reduce the usage of these ACs, and also we had to reduce the one in the refrigerators. That means we have to use the, we have to come to the olden days one, and we have to use the pots for the cold water like that, and we have to use the coolers. So in that way, to some extent, not completely, to the some extent, we can reduce the depletion of the ozone layer. So this is about the freons. Next one, very, very important, children, for your intermediate 2 marks question. So what is the full form of DDT? Every time they are asking, and what is the structure? See, what is DDT? Means para dichloro diphenyl trichloroethane. How we have to remember? See the structure, see, with which these are the 2 benzenes. So at which position to this benzene chlorine is attached? Chlorine attached to the para position of the benzene. See, children, here chlorine attached to the para position. So therefore, how many chlorines are there here? 2 benzenes, 2 chlorines. Therefore, we have to name that one as para dichloro. So dichloro diphenyl. So how many benzenes are there? 2. So they're phenyl groups. So therefore, we are taken as para dichloro diphenyl. How many are there? 2. So therefore, diphenyl. And how many chlorines are attached to this carbon? See, this is 1 carbon. This is 1 more carbon. How many carbons are there? So 2 carbons are there. So here the one longest chain here will be the 2 carbons. When 2 carbons are there, what is the root word? Ith. So what is the root word? Ith. So all are single bonds. Therefore, we have to use that one as a ethane. To this ethane, how many chlorines are attached? 3 chlorines are attached. Therefore, we have to give the name as trichloroethane. Now clear, children? You can easily remember that. So 2 phenyl groups are there. 2 chlorines at which position? Para position. Therefore, para dichloro diphenyl. And how many chlorines? Trichloro, 3 chlorines. So how many carbons are there? See, 1, 2. So 2 carbons are there. Root word is ethane. So para dichloro diphenyl trichloroethane, DDT. Very, very important. Almost all, every time they are asking expansion of DDT, and also structure is also very important. Practice, children, easily you can score the 2 marks. So see here, this DDT is manufactured by the condensation of chlorol with chlorobenzene. So here what is happening, how it is going to be prepared means by condensation of chlorol with the chlorobenzene in presence of water, sulfuric acid. Then DDT is going to be prepared. Then DDT is going to be prepared in the industries. But see here, when come to the properties, it is a white powder insoluble in water. It is a white powder insoluble in water, and it is highly stable fat-soluble compound. It is highly stable fat-soluble compound. These are the some of the properties of DDT. And uses of DDT. So where we are using this DDT means it is mainly used as insecticides. So in olden days, previously we used this one as an insecticide. But so due to some environmental hazardness one, it is banned in USA 1973. So why they banned means this DDT, when they are used as an insecticide, what happens? It is going to be increase the larva of the mosquitoes more, and so that the mosquitoes will be stable, and due to this more number of the mosquitoes are going to be entered into the environment. Therefore, it is one of the environmental hazardness, and also due to this usage, so fishes are also also going to be affecting. Therefore, this was banned in USA in 1973. But still in some other countries, some other parts of the world, they are using as an insecticide, but it is having the so many environmental hazardness. So this is about DDT. So this is also one of the compound come under the polyhalogen compound. Why? Because just now we saw in this structure, so more than one halogen is going to be present. Therefore, we are calling that one as a polyhalogen compound. So these are all the polyhalogen compounds. So what we discussed here, so dichloromethane, trichloromethane, chloroform, triiodomethane, so that is iodoform, and carbon tetrachloride we learned, and also we learned the freons, and also we learned the DDT. So all these are the one comes under the polyhalogen compounds. So with this we completed the haloarenes. Children practice well all the one. So in this session what we learned: classification of haloarenes, nomenclature, methods of preparation by electrophilic substitution, Sandmeyer reaction, Gattermann's reaction, and we discussed the physical properties, chemical properties of haloarenes. Under that, we discussed the nucleophilic substitution reactions, electrophilic substitution reactions, reactions with metals, and polyhalogen compounds. So, and their properties, uses we discussed. All these things are very, very important for your IPE as well as for your entrance exams also. Practice well. So first of all, the organic chemistry will be difficult one, but if you feel difficult, it will be a difficult one. So if you practice more, so that it will be easy and you can score the full marks in your IPE, not only IPE, in your entrance also you can score the marks easily. Practice well all the reactions, children. So, and practice, these are the questions. Just now we discussed everything here. So practice Friedel-Crafts reactions, Wurtz-Fitting reactions, and also polyhalogen compounds. We discussed mainly the carbon tetrachloride, freons, DDT, concentrate on DDT, and here freons, chloroforms, properties that you can know, and be thorough with the structure of the DDT. Okay, first of all, I thank all the webinar team for giving me this opportunity, madam. Thank you for all. Thank you, madam.
Thank you, Archana madam. So really it was a very wonderful session. And dear children, madam has extensively explained you regarding the polyhalogen compounds. See why? Because in our textbook, just you can find only about the DDT. Isn't it, madam? Only we can see the structure of DDT, right? But she has given you all the preparations of polyhalogen compounds and their properties and their uses. See, their applications are very important. And she has very clearly explained you about the DDT. Isn't it? See why DDT was banned? Because the insects have developed resistance towards this DDT. Okay, and then she has clearly explained you about the Friedel-Crafts reaction, Wurtz-Fittig reaction, Fittig reaction. Okay, and then in our last session, that is the session which we had yesterday, she completed about the Sandmeyer's Gattermann's reaction. See, dear children, so please feel free to ask the doubts regarding this organic chemistry with your teachers. Please clarify your doubts. And then if you have any queries, you can post in the chat box. See, we will be available. We can answer your questions also. And then please go through our webinar sessions, right? So thank you one and all for giving this opportunity. Thank you, Archana ma'am.
Thank you, ma'am.
So you clearly explained each and everything about the haloarenes and polyhalogen compounds. So thank you very much. Thank you.
Thank you, ma'am. Thank you.